The following video is going to demonstrate how to work out whether two different atoms are isotopes of each other. I'm going to show you one model that we could use to do this using shorthand notation. You could also see this provided just the atomic mass of two atoms and the symbol. You could also be provided the drawing of the atom themselves to determine whether they're isotopes of each other or not. So in the first example here, I've got 2311 sodium as atom A, and I've got 2411 sodium as atom B. If I go through and I determine how many protons, electrons, and neutrons each of these has, we'll be able to determine whether these are isotopes of each other. To determine protons, we're looking at the bottom number here. And so in atom A, the atomic number, which is listed on the bottom, is going to be 11, and so atom A has 11 protons. Electrons are also going to be found by looking at the atomic number in this case, so atom A also has 11 electrons. To determine the number of neutrons, we're going to take the atomic mass, which is rounded on, and it's the top number, so 23, minus the number of protons, which is 11, and that's going to give us 12 neutrons. For atom B, we're going to do the same process. So its atomic number is 11, so it also has 11 protons. It also has 11 electrons. And then the subtraction to figure out its number of neutrons is going to show that it has 13 neutrons. So what we're dealing with here when we talk about isotopes is we need to compare the parts of the atom and see whether the number of protons and electrons are similar, or the atomic number similar. And so looking at this, sodium has 11 protons in atom A, it has 11 protons in atom B. That's the same. That's a good start. The other part of this definition, though, is that we have to have a different number of neutrons, or a different atomic mass. And so atom A has an atomic mass of 23, giving us 12 neutrons, so that's good. And then atom B has 24 for its atomic mass, giving it 13 neutrons. So between atom A has 12 neutrons, atom B has 13 neutrons, those are a different number of neutrons, and they have the same number of protons and electrons, indicating that these are isotopes of each other. Isotopes still have similar chemical and physical properties. Let's look at another example where we're comparing 14,7 nitrogen in atom A and 16,8 oxygen in atom B. So atom A has 7 protons, 7 electrons, 7 neutrons. Atom B has 8 protons, 8 electrons, 8 neutrons. What we're looking for here is they have to have the same number of protons as each other. So atom A has 7 protons, that means atom B also has to have 7 protons. In this case it doesn't, it has 8. So at no point are these possibly going to be isotopes of each other. The number of protons determines what type of element we're dealing with. 7 protons indicates atom A is nitrogen, 8 protons indicates atom B is oxygen. The rest of the information here really doesn't matter because it doesn't have the same number of protons, so we could stop this problem right here and identify that these are indeed not isotopes of each other. Thank you. I hope the video is helpful, and we'll have the next video in the series ready to go here soon.